All right, so this is the Unit 7C DEF test review. So finding the roots, we need to do this by factoring. And remember, always to factor, always find greatest common factor if there is one right away. So GCF, and we look at each individual term and what can you divide each individual term by. So 2, 2, and 60, that's 2, x to the third, x squared, and x. X is the smallest, so your greatest common factor is 2x. So the first step is to divide each term by 2x. And you'll get x squared, x, minus x. There's a minus here, so subtracting x. And looks like a 30, or 30, and that's it. All right. Then we're going to look, can we factor further? Can we factor the inside any further? You could think two numbers are multiplied to 30, a times c. So 1 times 30 is 30. What two numbers multiply to 30? That'll add up to -1. So you could think 5 times 6, but that adds up to 11. -5 times -6 adds up to -11. Those multiply to positive 30. But I'm not finding anything else that would add up. So that tells me we can't factor. So in this case, we are going to split this up. We're going to have one of our factor, greatest common factor, is going to equal 0, and our other factor, the trinomial, equals 0. Now we can do more with this. The first factor is going to be 0, so that's going to be one of our solutions. Next, we're going to have our A, B, and C. And this is lining it up for the quadratic formula. So the quadratic formula, we have x equals the opposite of b plus or minus b squared minus 4 times a times c, all divided by 2 times a. Opposite of -1 is +1. -1 squared is +1. 4 times 1 times 30 is -120, or -120, over 2. And let's keep simplifying. X equals 1 plus or minus 1 minus 120 is -119, divided by 2. And then the only thing we can simplify there, we look to simplify this square root, and that would be I squared of 119. 119 is a prime number, I believe. So it's going to be I square root of 119 divided by 2, nothing to simplify. Those would be your other two answers. So we have one with x equals 0 and two solutions with 1 plus I squared of 119 over 2 and 1 minus I squared of 119 over 2. All right, next, number 2. We have, first let's get all the terms to one side. So then we want the equation equals 0. So x to the 4th minus 10x squared equals -24. We could have done this in the same step. Kind of ran out of room though. So adding 24 equals 0. So you need to make the equation equal 0. Then this one is kind of quadratic-like. If you see to the 4th and it's 3 terms, then we can see if we can do a times c, we can factor. So 1 times 24 equals 24. What two numbers multiply to positive 24? That'll add up to -10. And that would be -6 and -4. That multiplies to positive 24. That adds up to -10. All right. So Punnett Square. X to the 4th, first term top left, last term bottom right. The two numbers we just came up with will go in the other two blanks. They have to add up to the middle term, so we'll have x squared on both. Take out your greatest common factor of each row in each column, so -6. It's negative because of the first term's negative. We have x squared, and -4. Again, that's a negative because of a negative. Rewriting now, we have x squared minus 4, x squared minus 6. This is going to equal 0. So There are factors. Can we factor it further? We certainly could. The x squared minus 4 is a difference of squares. But you can also, with the b missing, so you have your a term, no b term, but a c term, you can actually solve both of these without doing anything else. So you could factor the first one, not the second one, because you can't square root 6. But without a b term, you can solve by square roots. And I think it's probably the easiest way to do it. Just remember, anytime you square root, you have a positive and negative. You have x equals a positive and negative 2. So there's two solutions there, a positive 2 and a negative 2. And our other solution, square root, you have a positive and negative. A positive and negative square root of 6. And there's your other two solutions. There should be 4 total because our biggest exponent was 4 in standard form. All right, number 3. 4 terms. Looking to factor this. Doesn't always work, but 4 terms, put it in the Punnett Square, and we'll see if it works. First term top left, last term bottom right. The other two terms don't matter where they go. Take out your greatest common factor of each row. So bottom row is 2, top row is x squared, first column is x to the 4th, last column is negative 9. Rewriting those, x to the 4th minus 9, and x squared, that's a positive 2, so plus 2. Can we factor any of these further? Well, the first binomial, yes, both square rootable, and there's a subtraction in the middle, so it's a difference of squares. Square root of x to the 4th is x squared, so we'll have x squared and x squared. Square root of 9 is 3. One of the binomials is positive, one's negative. Can we do the same thing with the second one? Square root, you can't square root 2, so no. So then that's just, no, that's not factorable. And now we look, how can we solve these factors from here? Well, all of them are missing the b term. So we can set them equal to 0 and solve by square roots. So subtract 3. Square root. Don't forget, when you square root, you have a positive and negative answer. Positive, negative. Square root of negative 3 is I, square root of positive 3. Next one, you have plus 3. Square root. Don't forget, when you square root, you have a plus minus. And last one, square minus 2. Oh, don't forget the plus minus, Mr. Johnson. Square root of negative is I. Square root of negative 1 is I. And then there's 2. So here are all 6 answers. You have positive and negative each one. All right, next problem. Subtract 125 for number 4. Again, what we're doing here is we are setting the equation equal to 0 to see, can we factor it? Here is going to be one of those special cases where you can cube root the first term and last term, and my key here was looking at the cubic. That means you should be able to try to cube root it. That's 4x and 5. If you can cube root, and there you see there's a subtraction here, that's called difference of cubes. So your a is 4x, your b is 5. So we have a minus b, a squared, opposite of the first sign, a times b, now always positive, b squared. And that should be from last unit. 4x squared, so that means 4x times 4x. What do I have equals? Is 16x squared plus 20x plus 25, that equals 0. I should have equals 0 here also. All right. Looking at this from now, we have factors, set each factor equal to 0, and kind of think about how you can solve them. So the first factor, linear, you can solve, you can get x by itself without much trouble, hopefully. So we get x equals 5/4 as an answer. That is a solution. And the next one, we have an A term, B term, and C term. I'm just going to go straight to the quadratic formula. It's quadratic, so we can, anytime you have a quadratic, you can use a quadratic formula. So x equals opposite of b plus or minus b squared minus 4 times a. These are going to get some big numbers, but that's all right. So we got calculators for 2 times a. First step, 200 squared is 400. 4 times 25 is 100, times 16 is negative 1600. Yep. And 32. Negative 20 plus or minus negative 1200 over 32. This is going to get ugly. Negative 1200. I'm going to put that over on the side. That's 206. 2 and 3. 200 is 20 times 10. 5 and 2. 4 and 5. 2 and 2. All right, not as bad as I thought. Looking at, how does that simplify? We have pairs. Look at all our pairs. We have pair of 2s, pair of 5s, and another pair of 2s. All right, not too bad. 2 times 2. So this is going to end up being square root of negative 1200 is 2 times 2 times 5. Don't forget the I, and then looks like there's only a 3 left over. So 3. So 2 times 2 is 4 times 5. 20i square root of 3. Okay. I don't know if I'm going to have enough room for this. X equals a negative 20 plus or minus 20i square root of 3 over 32. Looking to simplify. They're all divisible by 4, I think is the biggest. Yeah. So dividing each term by 4, you'll get negative 5, 5, and 8. And I'm running out of room. X equals a negative 5 plus or minus 5i square root of 3 over 8. And give yourself a high five if you followed all that. Well, there's 2 answers there. There's also, don't forget about the third answer, 5/4. So that is all of 7C. Oh no, it's not, I lied. Here's one more. Why not? Let's throw one more at you. Looking to factor, greatest common factor is x. And inside, can we factor it further? Sure can. You can actually cube root both terms, and it's an addition in the middle, so it's going to be sum of cubes. So we have x on the outside. Well, let me do the inside first. So we have x, same sign as it started with x. It's plus 8, so it's plus 2. X squared minus 2 times x plus 2 squared is 4. And then the x is going to come down, equals 0. Set each factor equal to 0, see what, and then solve how you need to solve. Oh my goodness. Can't even copy stuff down. First, x equals 0, that's already a solution. X plus 2 equals 0, not a solution, but when we subtract 2, you're going to get x equals negative 2, so that's the solution. And the last one, we have A is 1, B is negative 2, and C is 4. I'm going to use quadratic formula. Anytime you're using sum or difference of cubes, you just got to use the quadratic formula. Opposite of negative 2 plus or minus negative 2 squared minus 4 times A times C. So we have smaller numbers on this one. That's wonderful. 2 times A. 2 plus or minus 4 minus 16 over 2. So I'm going through the factor trees. Pair of 2's, don't forget the negative will come out as I, so it's 2i squared of 3 So we'll rewrite square root as 2i squared 3 over 2, and then we're looking at those three terms, the coefficients, and seeing can we simplify them, and sure can. We can divide them all by 2. Now you got to be careful. This is a term, so the 1 has to stay there. This one, the second one, when you do 1 times I, that's I. So that 1 kind of looks like it disappears. And then when you divide by 1, you don't actually need it. Anything, you can always put something over 1. So we don't actually need that division. And this would be your final answer there. So there are two answers actually, 1 plus I squared root of 3 and 1 minus I squared root of 3. And then don't forget about our answers at the very beginning here. So I'm going to highlight all of our answers. 0, -2, and then the two answers here. All right, that is all of 7C. 7D, identify the number of zeros. Biggest exponent, looking through. And so there'll be 7 zeros. That's the biggest exponent. Suppose a polynomial function f has at least 2 real zeros, so 2 real, at least 2, and at least 3 imaginary. The graph of the function crosses the x-axis 3 times. So 1, 2, 3. It has at least 2 real and at least 3 imaginary. So it has, if it crosses 3 times, that it has to have 3 real. At least, that's the smallest amount. It could touch 1, 2, 3, so that would actually be 1, 2, 3, 4, but we want the minimum degree, so we want the smallest. So the smallest would be all single solutions, so 3 real, 3 imaginary. Imaginaries cannot come in odd numbers. It's got to be even, so the smallest even number to a 3 would be 4, so it has to be 4 imaginary. So total there's, so you add that up and there's 7 total solutions. So that's the smallest, which means that would be 7 would be minimum degree. So 7 is your minimum degree. Polynomial has at least 1 imaginary, so they cannot have 1, so at least 1, so it's really at least 2 because it's got to be even. We got to look at, this is whether you say it's 1 solution or 2. If it's a max there, then it's 2. If that's a maximum point, that's a unique solution that has 2 solutions. We count it twice. Or you could think that it crosses twice. It's kind of an iffy looking problem. Might be 2 solutions really close to each other. But there are 2 real solutions. And we cannot have 1 imaginary. So that has to be 2 imaginary. So 2 plus 2 is 4. So it's degree 4. For a 7th degree polynomial below, find the number of real and imaginary solutions. So we have 2 x-intercepts. First one goes through at a very straight line, so that's 1 solution. And this is the next time it hits the x-axis, it forms a quadratic. Quadratic is 2 solutions when it forms around the x-axis. Or you could think of it as a local minimum. So there's 1 plus 2 is 3, so there's 3 real. And the 7th degree means there are 7 total solutions. So that means the other 4 have to be imaginary. All right, for number 10, we need to look, so it's 5 total solutions. And then we need to put this into Desmos, which I do not have prepared for you, so you're going to have to hold on. X to the 5th minus 4x to the 3rd plus 3x squared. Looking at our x-intercepts, well, we have a double solution at 0, another one single at 1, and a single at 1.3. So 2 at 0, 3, 4. So there are 4 total real solutions. Did I type something? Oh, I did type it in wrong. My bad. Hope you're yelling at me right now. Saying, Mr. Johnson, that's wrong. And now I totally got it wrong. Oh my goodness, way different, way different. 1, 2, 3, 4, 5. All are single solutions. Oh my gosh, way different. So there are 5 real solutions, and that tells you there's 5 total, 5 real, so that'd be 0 imaginary. Oh my goodness. Whoa. All right, right in the zeros. All right, first step, set each 0 equal to x individually. Now make each 0 equal to, or make each equation equal to x, or equal to 0. So here's your factors, so we're really finding factors here. There's your factor x minus 3, and I know this looks very strange. But x minus 6 square root of 3 is your factor. X plus square root of 3 is your factor. Now we're going to write it in factored form of the polynomial. So each factor is going to write next to each other. And now we got to look at multiplying this out. You can only multiply 2 factors together at a time. So I'm going to split this up so there's 2 factors on each side of my line. And that will tell me that I can multiply both of them actually. But not together. They're going to be separate, but both. 7x plus 2, x minus 3. 7x squared, 2x, negative 21x, negative 6. So we have 7x squared minus 19x minus 6. And now we got to do the Punnett Square over here. This one's going to be a little bit more tricky, but we can get through it. I know we can. X squared, negative 6x squared root of 3, positive 6x squared root of 3. And multiply the outsides of the radicals, multiply the insides of the radicals. And looking to simplify, we got like terms, but they're opposites, so those actually equal 0. Square root of 9 is 3. 3 times negative 36 is negative 108. So this actually equals x squared minus 108. All right, and then we have to multiply those, a trinomial times a binomial. I'm going to do that over to the side here. Seven x squared minus 19x minus 6. X squared minus 108. 7x to the 4th minus 19x to the 3rd minus 6x squared. 108 times 7, that's 756, I believe. If it's not, you're probably yelling at me. I'm not going to be able to do 19 times, or negative 19 times negative 108 in my head. Oh my goodness. What am I doing to you guys? And negative 6 times 108. 648. Like terms, we should have some somewhere. Looks like we do. They're kind of wonky though. There's your like terms. So we have 7x to the fourth minus 19x cubed plus 750x squared plus 2052x plus 648. And that is going to be equal f of x equals, or y equals. There you go. Oh my goodness. Wild. All right, next problem. Moving on. So number 12, roots of, set the roots x equals, wait a second. You can't have one imaginary solution. Here's the problem. This has a positive 3i. There has to be the opposite, the conjugate of it. So there has to be a negative. Well, I didn't say that, so it's kind of tricky, but there has to be a negative. So there actually are three solutions here. You have to have even number of imaginary. And if there's a positive imaginary, there's always a negative with it. Setting each factor, or finding each factor. So x plus 4, x minus 3i, x plus 3i. Write it in factored form. That is not even close, Mr. Johnson. You can only multiply two factors together at a time. I'm actually going to take the second two. X minus 3i, x plus 3i. Multiply them out. When you multiply conjugates, they always work out nice. So we have your middle terms, positive 3xi, negative 3xi, simplify. I squared is negative 1, negative 9 times negative 1 is positive 9. So we have x plus 4 and x squared plus 9. And we need to now multiply these out. I'm going to do this over here since there's a little room. X plus 4, x squared plus 9. Multiply them out. Oh my goodness. I am all over the place. And that was totally wrong. That should be x to the third. Plus, there are no like terms, so we're just writing them out horizontally. And there's your polynomial. Write an equation. Let's see here. Well, that's tough to find. Oh, we're going to have to estimate this. So 2, 4, 6, 8, negative 10. So that's negative 2, that's negative 4. So in between is negative 3. So x equals negative 3. We'll estimate it. And we'll estimate that at negative 1. This is at 2, 4, 6, 8, 10. So that's at x equals 2, and that's a double. So we have x equals negative 3, x equals negative 1, x equals 2. We're going to write that twice so we can get the right polynomial. All right, your factors. And write it out just because, but you don't have to. The second one, and here are all your factors. Set those in polynomial factored form. Look to multiply them out. And you don't have to do this, but I do this in the order. I always put, if there's 4, I always do like 2 and 2. You're still only multiplying 2 at a time. You're just splitting it up. So x squared, 3x, 1x, 3. So that's going to be x squared plus 4x plus 3. What's this other one? X squared minus 2x plus 4. So that's x squared minus 4x plus 4. It's getting wild here. All right, now we have a trinomial times a trinomial. Oof. All right, well, you got to do that. So got to do a 3 by 3. X squared 4x plus 3. X squared minus 4x plus 4. X to the fourth, 4x cubed. 3x squared, negative 4x cubed, 16x squared, negative 12x, 4x squared, 16x, and 12. Now we just got to figure out all of our like terms. And we have x to the fourth, not a like term of anything. We got our two like terms here. They're lined up. Oh, those are opposites. Nice. And another like term, so there's nothing there. 23, those add up to. So plus 23x squared. Looks like we got some more like terms coming up here. That's a 4x. And then 12 at the end. And there is your polynomial that would give you those four. Negative 3, negative 1, and a double at 2. Number 14. So this is negative 5, so that's negative 1, negative 2, negative 3, negative 4. Okay, so that's at x equals negative 3. This is x equals 0, but that's a multiple of 2. That's a double, forms that quadratic, the minimum point. Anytime there's a local minimum or max hitting the x-axis, that would be called multiple of 2. So we have at 3, I'm just going to find the factors to save some more room here. 3, x equals 0, and another x equals 0. Your factors are 0 or x. Next one is negative 5. So you get 2 negative x equals negative 5s. So we have factored form is x. Most of the time you write monomials first, then binomials, then trinomials. X plus 3, x minus 5 times x minus 5. So you can multiply any order you want. I would actually split it up kind of like this. X times x is x squared. That's easy. And then x minus 5 times x minus 5 can be pretty straightforward. And if you multiply these out enough, you probably already know the answer. You know that the negative 5s, you're going to add those up. And that's going to be negative 10x, and then negative 5 times negative 5 is positive 25. Some of you have already been picking up on that, I'm sure. Let's distribute in this x squared, so that's x cubed plus 3x squared. Now we have a binomial times a trinomial, so we got to work that out. So x cubed times x squared, like bases add exponents. Like bases add exponents again. 25x to the third. Like bases add exponents, so to the fourth, add exponents, multiply the coefficients, x to the third, and 75x squared. Ooh, let's look at our like terms, put them together, and we are done. So x to the fifth is no like term there. That's going to be a negative 7x to the fourth. Those two like terms is going to add up to negative 5x cubed, and at the end, 75x squared. That is your polynomial. That would give you those zeros. All right, dividing polynomials. Dividing polynomials, so we're going to work these out. I'm going to do it long division. I know I showed a different way of doing this, but we're going to do long division for here. If you work it out the other way, the newer way with the Punnett Square, you're going to get the same answer. So first term divided by first term, so 30m cubed divided by 6m is 5m squared. Multiply times 6m. Multiply 5m squared times a negative 9 is a negative 45m squared. Looking to subtract these. Subtract the first terms. Those will simplify to 0. Subtract, so the opposite of negative 45, which is plus. That's going to be a 24m squared plus 24m. And you do like first term divided by first term, so 24m squared divided by 6 is 4m. Now we're going to multiply that back down. 4m times 6m is 24m squared. 4m times negative 9 is negative 36m. And subtract 24m minus 24m. Those will simplify to 0. Opposite of negative 36m is a positive, so 24 plus 36 is 0, carry the 1, 60m. And we bring down that negative 90, and let's do this. So we do first term divided by first term. 60m divided by 6 is 10. 10 times 6m is 60m. 10 times negative 9 is negative 90. And this is going to be wonderful. Distributing the negative, you get simplified. Opposite of negative 90 is a positive. That means you get a remainder of 0. And that's awesome. So 5m squared plus 4m plus 10 is your answer. Is 8x minus 8 a factor? So we need to do long division. I did skip the last one. I didn't look at the exponents, but it's 3, 2, 1. So the exponents aren't skipped. The last problem was the same thing. Did not skip. Looking at your first term divided by first term, so 24x cubed divided by 8 is 3x squared. 3x squared times 8x is 24x cubed. 3x squared times negative 8 is negative 24x cubed. Look to subtract. Subtract. 24 minus 24. Opposite of negative 24 is positive, so that's 8x squared. Bring down the next term. First term divided by first term is x. X times 8x is 8x squared. X times negative 8 is negative 8x. Subtract. First terms will simplify. Opposite of negative 8 is a positive, so that's negative 56x. Bring down to 65. Negative 56x divided by 8 is a negative 7. Negative 7 times 8x is a negative 56x. Negative 7 times negative 8 is a positive 56. When we subtract these, first terms simplify. Opposite of a positive is negative. So that is going to become 9. So it's going to have a remainder. So 8x minus 8 is not a factor. Next, 17, we have x. So anytime I see you're dividing by a coefficient of 1, I would absolutely do synthetic division. So exponents go 3, 2, 0. We're missing to the first, so we need to add that, make sure that's in. We need to put that into our polynomial. So coefficients are 1, positive 2, 0, and 3. Got to figure out what goes in the box, the little half box here. If you want to actually draw a box, you can. It's always the opposite. Negative 2. Bring down the first term below the line. That's your first coefficient of your answer. Negative 2 times 1 is negative 2. Add 0. Negative 2 times 0 is 0. Add 0, 0, 3. So your remainder is 3. Exponents, always one less than the biggest exponent is where you start. So it's going to be 1x squared plus 0x to the first plus 0 with a remainder of 3. That really just boils down to x squared, and a remainder of 3 would be plus 3 over what you were dividing by, your divisor. All right, next. Oh my goodness, what is this mess? I'm going to rewrite the polynomial in standard form. Who would do something like that? Again, the coefficient is 1, so I'm going to put this, I'm going to go for synthetic division. So we have 1, 7, 13, 15, 3. Those are going to be your coefficients you're going to write down. X plus 1, so it's always the opposite when you have a coefficient of 1, so it's going to be negative 1. Negative 1 times 1 is negative 1, we add. Negative 1 times 6 is negative 6, we add. Negative 1 times 7 is negative 7, we add. Negative 1 times 8 is negative 8, we add. Last number is your remainder. We look at what our biggest exponent was, is x to the fourth. So we're going to start off with our answer is 1x, 1 less than the fourth to the third. And then we step it down 1 exponent at a time. X is x squared plus 7x to the first plus 8 x to the 0, but we actually don't need x to the 0 because that's 1. So we'll just say plus 8 with a remainder of negative 5. And cleaning this up, we have 1 times x cubed is x cubed plus 6x squared. 7x to the first is just 7x plus 8 with a remainder of negative 5, or you could have just minus 5 over x plus 1. And that is your test review.